Problem 2.6. Two rods of equal diameter and equal length but of different thermal conductivity are being used as fins. The rods have one end at 159 degrees Celsius while the surrounding is at 28 degrees Celsius. The end temperature of one rod is 100 degrees Celsius while that of the other rod is 80 degrees Celsius. If the thermal conductivity of one of the rod is 380 watt per meter Kelvin, calculate the thermal conductivity of the other rod. The fins can be assumed as a short fins with end insulated. So in order to solve this problem, let us draw the schematic first. So in the given problem, two fins of different material having thermal conductivity K1 and K2 are attached to the base surface and are used as fins. Let's say the base surface temperature is at Ts. Both these fins are of same length and same diameter, and these values are capital L and small d respectively. That is d1 is equal to d2 is equal to d. Let's say both these two rods are exposed to the surrounding at temperature T infinity and convective heat transfer coefficient H. So this is the required schematic of this problem. So title of the figure will be two rods used as fins. After drawing the required schematic, let us enlist all the given parameters. So the rods have one end at 159 degrees Celsius. That is, this is nothing but base temperature because it is common for both the rods, and surrounding is at 28 degrees Celsius. So the base surface temperature is 159 degrees Celsius and the surrounding temperature is at 28 degrees Celsius. The end temperature of one of the rod is 100 degrees Celsius while that of the other rod is 80 degrees Celsius. End temperature means temperature at this end. So TL1 is 100 degrees Celsius for one of the rod, let's say first rod, and TL2 is 80 degrees Celsius for second rod. Thermal conductivity of one of the rod is 380 watt per meter Kelvin. Let's say thermal conductivity of the first rod is 380 watt per meter Kelvin. So you are supposed to calculate the thermal conductivity of the other rod. Let me check whether the value of H is given or not. Okay, it is not given. Now, in order to solve this problem, let us make assumptions. So assumption number one dimensional steady state heat transfer. Assumption number two, no heat generation within the fin itself, that is Qg is equal to 0. Assumption number three, no thermal contact resistance between base surface and fin root surface for both the fins. That is why their root temperatures will be at 159 degrees Celsius. Assumption number four, homogeneous and isotropic material of both the fins. That means K1 and K2 will be constant for both the fins. Then uniform fluid properties, that is H will be constant for the surrounding fluid, and both the fins are insulated tip fins. So these are the required assumptions. Let us enlist what is to be found out. So in this problem, we are supposed to calculate thermal conductivity of second material. So let us do the required calculations. So in order to calculate this thermal conductivity of second material, let us first recall the temperature distribution equation for insulated tip fin. And for insulated tip fin, temperature distribution at the distance x from the base surface, that is, let's say this represents x equal to 0 and this represents x equal to L. So at a distance x from the base surface, temperature distribution will be Tx. So this Tx can be found out by this formula. So for that, once again we can use data book. I am using Kothanda Raman's data book, and this formula is given by, for insulated tip fin, Tx minus T infinity over Ts minus T infinity is equal to cos of hyperbolic m into L minus x over cos of hyperbolic ml. Let's say this is equation number 1. Now, in the given problem, we have been given some end temperatures, that is temperatures at x equal to L or temperatures at the tip of the both of the fin, 100 degrees Celsius and 80 degrees Celsius. So we have to modify this equation for the temperature at the tip of the fin. So at the tip of the fin, that is at x equal to L, Tx will become Tl. So equation 1 will reduce to TL minus T infinity over Ts minus T infinity is equal to cos of hyperbolic m into L minus L over cos of hyperbolic ml. So this will become cos of hyperbolic 0 over cos of hyperbolic ml. After simplifying this, after taking the value of cos of hyperbolic 0, the temperature distribution at the tip of the fin will reduce to 1 over cos of hyperbolic ml. Let's say this is equation number 2, and cos of hyperbolic 0 is nothing but 1. Now let us write down this temperature distribution for fin 1. So for fin 1, it becomes TL1 minus T infinity over Ts minus T infinity is equal to 1 over cos of hyperbolic M1 L M1 L1. So one more thing I can mention here in the given for the sake of more clarity, diameters of both the fins are same and lengths are also same. So for fin, after putting the values 100 minus 28 over 159 minus 28 is equal to 1 upon cos of hyperbolic M1 L1, this will become, after solving this entire term, this will become cos of hyperbolic M1 L1 will be equal to 1.8194. Taking the inverse of cos of hyperbolic, it will become M1 L1 is equal to 1.205. Let's say this is equation number 4. Similarly for fin 2, so TL2 minus T infinity over Ts minus T infinity is equal to 1 over cos of hyperbolic M2 L2. Putting the values of all these temperatures, that is 80 minus 28 divided by 159 minus 28 is equal to 1 over cos of hyperbolic M2 L2. So after solving, it will become cos of hyperbolic M2 L2 is equal to, this value comes out 2.5192, and hence the value of M2 L2 comes out, that is, I can take in this fashion, cos inverse of this 2.5192. So the value of M2 L2 becomes 1.575. Let's say this is equation number 5. So we have M1 L1 is equal to 1.205 for fin 1 and M2 L2 is equal to 1.575 for fin 2. So let us do equation 4 divided by equation 5. So it will give me M1 L1 is equal to M2 L2 is equal to 1.205 over 1.575. L1 will get cancelled because L1 is equal to L2 is equal to 10. So what I will get? I will get M1 over M2 is equal to 0.765. Now I can put the value of M, that is nothing but HP over AAC. So I can put here H into E1 over A1 AC1. This is square root of M into H into P2 into A2 into AC2. This is the square root of M1 over M2. Now as both the fins of same length and same diameter, so their cross-sectional area will be same, their perimeter will be same, both are exposed to the same environment, so H value will also be same. So what I will get, after simplifying, I will get square root of K2 over K1 is equal to 0.765. The value of K1 for the fin 1 is 380 watt per meter Kelvin. So this will become K2 over 380 is equal to 0.765. So after solving this, I will get value of K2, that is thermal conductivity of second rod, as 222.88 watt per meter Kelvin. So this is the answer of this given problem, and this way you can solve this numerical.